So in our last class, I have already started the system of linear equation. Okay, that means we have to check the consistency of a system of linear equation. So with the help of rank, we can define whether a system of linear equation is consistent or not. Okay, so I repeat once again, see. So when a system of equation is said to be consistent, if rank of A equal to rank of C. So rank of A means what? A means what? A is the matrix. A is this matrix. This one, see. A is this matrix. That means the matrix obtained by the taking the coefficient of the variables. Okay, A11, A12, A11. This is the matrix A, and this is the matrix B. Clear? This matrix C means what? A is to B. Matrix C means what? A is to B. This matrix is called actually what? Augmented matrix. Clear? This matrix is called augmented matrix. Now, if the rank of A is equal to the rank of C, that means augmented matrix. If the rank of A is equal to rank of C, that means if the rank of the matrix is equal to the rank of the augmented matrix, then we can say that the system is consistent. Okay. Now there are two conditions. If rank of A equal to rank of C equal to n, n means number of unknowns. So number of unknown means what? These are x1, x2, x3 up to xm. Okay, these are called x1, x2, xm. These are called unknowns. Clear? Number of unknowns. If these are equal to the number of unknowns, then we can say that the system has unique solution. Suppose rank of A is also 3, rank of C is also 3, and the total number of unknowns, suppose x, y, z, that means 3. Then what happened? The system has an unique solution. Clear? And when it is infinite solution, if rank of A equal to rank of C equal to some value which is less than to n. Okay, which is less than to n, then the system has an infinite number of solutions. Okay, now come to the point, inconsistent equation. That means inconsistent equation means what? There is no solution. So if rank of A not equal to rank of C, if rank of A not equal to rank of C, then what happened? The system has no solution. Okay. So as I will see here, this is system of non-homogeneous linear equation Ax equal to B have consistent if rank of A equal to rank of C, and inconsistent, that means no solution, if rank of A not equal to rank of C. If rank of A equal to rank of C, then the system is consistent, and if rank of A not equal to rank of C, then the system is inconsistent. Now in this case, two cases are arises. So one is unique solution when it is equal to number of unknowns, and it is infinite solution when it is less than to the number of unknowns. So let's try some problems. See here. So that the equations 2x plus 6y minus 11, these three equations are given, are not consistent. Okay, are not consistent. That means the system has no solution. So now see what is the augmented matrix. C is to B. So here coefficient of x is 2, coefficient of y is 6. There is no z, so obviously coefficient of z will be what? Coefficient of z will be 0 is to minus 11. Okay. Again, this is a coefficient of x is 6, coefficient of y is 20, coefficient of z is what? Minus 6 is 2. Here it is minus 3. And the last one, there is no x, so coefficient of x is equal to 0, coefficient of y is equal to 6, and coefficient of z is equal to minus 18 is 2. This is minus 11. Okay. Now see, we can easily we have to, after that we have to make this augmented matrix into triangular form. Okay, we have to transform this matrix into triangular form. Okay. Now see, we can easily make this element equal to 0 by using this one, because 6 minus 2 into 3, which is equal to 0. So row 2 tends to row 2 minus 3 row 1. Row 2 tends to row 2 minus 3 row 1. So 6 minus 6, which is equal to 0. 20 minus 6 3 is 18, which is equal to 2. Again, minus 6 minus 0, it will be obviously minus 6 is 2 minus 3 minus minus plus 33. So it will be 30. Clear? So what you got? 2 minus 6, 30. Now see, by using this one, we can easily make this element equal to 0. Okay, by using this one, we can easily make this element equal to 0. How you can make this equal to 0? 6 minus 2 into 3. 6 minus 6, it will becomes equal to 0. So, so row 3 tends to row 3 minus 3 row 2. Row 3 tends to row 3 minus 3 row 2. So what you got? This 6 minus 3 2s are 6, so it will be equal to 0. Minus 18 minus 3 into minus 6. Okay, so minus minus, it will becomes plus. So minus 18 plus 18, it will be 0. Again, minus 1 minus 3 3s are 90, so it will be minus 91. Okay. Now you see here, this the matrix left hand side of the is 2 is the matrix A. Clear? Here this is the matrix A. Here how many non-zero rows are there? Only 2. This one and this one. Last one is the what? 0 row. So what is the rank of the matrix A? This matrix, that means rank of the matrix A is what? 2. Now see the whole matrix. This is the augmented matrix. See here, how many non-zero rows are there? There are 3 non-zero rows, because the last row is also non-zero since minus 91 is there. Clear? So from here, what you got? Rank of the matrix A is equal to 2, and the rank of the augmented matrix C is equal to what? 3. So obviously, if rank of A not equal to, if rank of A not equal to rank of C, this one, if rank of A not equal to rank of C, then what happened? The system is inconsistent. That means it has no solution. Okay, that means it has no solution. So in this case, since rank of A is not equal to rank of C, that means the augmented matrix, that's why the system has no solution. Okay. Next, see the next question. Okay. See the next question. Test the consistency and hence solve the following set of equations. Okay, so this is a system of equations. So how many equations are there? 4 equations are there. How many unknowns are there? 3 unknowns. These are x1, x2 and x3. These are the 3 unknowns, x1, x2 and x3. So the given set of equation can be written in the matrix form as well. So 1, 2, 1, 1 2 1, again 3 1 minus 2, 3 1 minus 2, again 4 minus 3 minus 1, 4 minus 3 minus 1, again 2 4 2, 2 4 2, and this is x1 x2 x3, x1 x2 x3 equal to 2 1 3 4. Okay, this is the matrix 2 1 3 4. So this can be written as what? A, this is the matrix A, this is the matrix X, and this is the matrix B. Now see what is the augmented matrix C. C is equal to what? A is to B. C is equal to A is to B. So this is the matrix A, this is the matrix A, and last column it is the matrix B. See here 2 1 3 4, 2 1 3 4. That means this is first three column is the matrix A, the last column is the matrix B. So as a whole it is A is to B. That means the augmented matrix. Okay. Now see here. Now since it is already 1, so by using this 1 we can easily make these elements equal to 0. Okay, so by using this 1 we can easily make these elements equal to 0. So how you can make this equal to 0? See here. So row 2 tends to row 2 minus 3 row 1. Okay, row 2 tends to row 2 minus 3 row 1. So by doing this calculation, we got 0, minus 5, minus 5, minus 5. Again, row 3 tends to row 3 minus 4 row 1. Similar way, we got this is also equal to 0. Okay. Again, row 4 tends to row 4 minus 2 row 1. See here, row 4 minus 2 row 1. That means 2 minus 2 into 1. So 2 minus 2 result is equal to 0. Again, 4 minus 2 into 2, that means 4 minus 4, which is also equal to 0. Again, 2 minus 2 into 1, that means 2 minus 2, which is also equal to 0. Again, 4 minus 2 into 2, that means 4 minus 4, which is also equal to 0. That means what you got? Whole last row is equal to 0. Okay, now see here, see the second row. Second row, its element is equal to what? Minus 5. So you can divide the second row by minus 5. See here, row 2 tends to minus 1 by 5 row 2. Row 2 tends to minus 1 by 5 row 2. So what you got? When we multiply with minus 1 by 5, you got 0, 1, 1, 1. Again, row 3 remains same, 0, minus 11, minus 5, minus 5. 0, minus 11, minus 5, minus 5. Now fourth row is 0, 0, 0, 0. Clear? Now see here, by using this one, we can easily make this equal to 0. How we can make this equal to 0? Row 3 tends to row 3 plus 11 row 2. Okay, row 3 tends to row 3 plus 11 row 2. So what you got? This 0 plus 0, 0. Minus 11 plus 11 into 1, that means plus 11, which is also equal to 0. Again, minus 5 plus 11, which is equal to 6. And minus 5 plus 11, which is also equal to 6. Now we can divide this third row by 6. So you got this one. Okay. Now see here, this is in the triangular form, or you can say it is in the echelon form. Now, is it possible to make these elements equal to 0? You can say that we can make this element equal 0 by using this one. But then what happened? These elements becomes non-zero. Okay, so it is not possible to make these elements equal to 0 without changing these elements. Clear? So that's why it is in the standard form, it is in the echelon form. Now see here, this first three column is the matrix A. First three column is the matrix A. Now see in the first three column, how many non-zero rows are there? See in the first three column, how many non-zero rows are there? There are 3 non-zero rows. See here, 1, 2, 3. Now again see the whole matrix, that means the augmented matrix. Now see how many non-zero rows are there. Again 3 non-zero rows are there. That means rank of C, C means the augmented matrix, equal to rank of A means this first matrix is equal to 3. 3 means number of unknowns. See here, how many unknowns are there? 3 unknowns are there, x1, x2 and x3. x1, x2 and x3, these are the only unknowns. So rank of the matrix is equal to what? The number of unknowns. So since it is equal to the number of unknowns, so what happened? Therefore, the system has an unique solution. Okay, since rank of the matrix is equal to the rank of the augmented matrix is equal to the number of unknowns, so therefore what happened? The system has an unique solution. Okay, now see how we can find out the solution. Now see here, this is the first matrix 1 2 1 0 1 1 0 0 1 0 0 1 0. Okay, so we transform this matrix, transform the matrix A to this form. Okay, we transform the matrix A into this form, again the matrix B into this form. Clear? So initially we got Ax equal to B. See here, initially we got Ax equal to B. We transform the matrix A to that matrix and transform the matrix B to that matrix. Okay, so therefore what happened? In place of A, you can put this one 1 2 1 0 1 1 0 0 1 0 0 0. So in place of A, we put this matrix. Now this is the matrix X, this is the matrix X, and this is the matrix B. It is 2 1 1 0. Okay, now we have to multiply this one. So what we got? See here, 1 into x1, so it will be x1 plus 2 into x2, so it will be plus 2x2 plus 1 into x3, that means plus x3 is equal to what? 2. Again, if you multiply 0 into x1, 0, 1 into x2, it will be x2 plus 1 into x3, it will be x3 equal to what? 1. This is 1. So again 0 0 1, so 1 into x3 equal to 1. Okay, so x3 is equal to 1. So now see here, if you put x3 equal to 1 in equation number 2, if you put x3 equal to 1 in equation number 2, then what you got? X2 equal to 1 minus 1, which is equal to 0. So x2 is equal to 0. Again, put x2 equal to 0 and x3 equal to 1 in equation number 1. Then what happened? x1 is also equal to 2 minus 1, which is equal to 1. That means you got x1 equal to 1, x2 equal to 0, and x3 equal to 1. Okay. So in this way, we can find out the solution of a system of linear equation. Okay, in this way, you can easily find out the solution of a system of linear equation. Now, you ask me if is there any doubt? Is there any doubt? Any question? Okay, then let's try once more. See here. So test for consistency and solve. So 3 equations are given. Okay, 3 equations are given. We have to check whether the system is consistent or not. At the same time, we have to find out the solution of this system of equation. Clear? Now see. C is the matrix, A is to B, so A is to B. So 5, 3, 7. This is 5, 3, 7 is to B. B means what? 4. Again 3, 26, 2. 3, 26, 2 is to 9. So this is the 9. Again 7, 2, 10. 7 to 10 is to 5. So these ones. Okay. So this is the matrix. This is the matrix. A is to B. Clear? So this is the matrix. A is to B. Now we have to check whether this system of equation is consistent or not. Clear? Now from here, see, if you done some plus arithmetic process, then it is difficult to bring this element equal to 1. Okay, so that's why we directly divide this whole row by 5. Okay, whole row by 5, because here no need to no need to find out the inverse of the matrix. Simply you have to make the matrix into triangular form. So that is the only case. Clear? So that's why we divide the matrix, divide the first row by 5. So then what you got, 5 by 5, which is equal to 1. This is 3 by 5. Now it is 7 by 5. Now it is 4 by 5. Okay. So what we have done, row 1 tends to 1 by 5, row 1. Okay. Now see here, by using this 1, we can easily make this and this equal to 0. By using this 1, we can easily make this one and this one equal to 0. So how you can make this equal to 0? You know that 3 minus 3 into 1, which is equal to 0. So therefore row 2 tends to row 2 minus 3 row 1. Row 2 tends to row 2 minus 3 row 1. So 3 minus 3, which is equal to 0. Similar way, we make these calculations. Okay. Again for row 3, what you got? 7 minus 7 into 1. 7 minus 7 into 1. That means 7 minus 7, which is equal to 0. Okay. So same way we make this operation. Row 3 tends to row 3 minus 7 row 1. Clear? Now, after calculating, we got this one. Now see, from here, what you got? From here, what you got? We can divide this whole second row by 11 by 5. We can divide the whole second row by 11 by 5. Because it is a multiple of 11 by 5. See here, 121 by 5. That means it can be written as 11 into 11 by 5. This is already 11 by 5. This can be written as what? 3 into 11 by 5. So that's why we can divide by 11 by 5. So when you divide by 11 5, or here row 2 tends to row 2. After this step, see here, instead of doing this one, here it is done in this way. Row 3 tends to row 3 plus 1 by 11 row 2. Simply it done in this way. Row 3 tends to row 3 plus 1 by 11 row 2. That means minus 11 minus 11 by 5 plus 1 by 11 into 5. So if you calculate this one, you got these elements equal to 0. Okay. So if you calculate, you can do it in defined way, no problem. So if you calculate this one, your result is equal to 0. Okay. Now from here, what you got? After this step, you cannot make any of this equal to 0. Okay. That means it is not possible to make these elements equal to 0 without making this element equal to non-zero. Okay. So it is not possible. So therefore, this is directly in the echelon form. Clear? So this is the matrix, first matrix A. This is the first matrix A. So here, how many non-zero rows are there? How many non-zero rows are there? 2 non-zero rows are there. 2 non-zero rows. So rank of A is equal to 2. And see, the whole matrix is the matrix C. Okay. Whole matrix is the augmented matrix C. Now here, how many non-zero rows are there? 3 non-zero rows are there. Okay. 3 non-zero rows are there. So, sorry, 2 non-zero rows are there. That means the rank of A is also equal to 2, and the rank of the augmented matrix is also equal to what? 2. Okay. But how many unknowns are there? See here, how many unknowns are there? 1, 2, 3. So there are total 3 unknowns. There are total 3 unknowns, but how many non-zero, what is the rank? It is equal to 2. That means rank of the matrix or rank and the rank of the augmented matrix is less than the number of unknowns. Okay, is less than the number of unknowns. Now you already know when the rank of the matrix and the rank of the augmented matrix is less than the number of unknowns, then what happened? Then the system has an infinite number of solutions. Okay, if the rank of the matrix and the rank of the augmented matrix is less than the number of unknowns, then the system has an infinite number of solutions. So since it is less than number of unknowns, the system has infinite number of solutions. Now let's see how we can find out these solutions. See here. So this is the after transforming the matrix into this form. So this is the matrix A. Again, this is the matrix X, and this is the matrix B. Okay. So once we multiply this one into X, so it will be X plus 3 by 5 into Y. That means 3 by 5Y plus 7 by 5 into Z, that means 7 by 5Z, equal to what you got? Equal to this is 4 by 5. And second equation, 0 into X, obviously it is 0. 121 by 5 into Y, so 121 by 5 into Y, minus 11 by 5 into Z, so minus 11 by 5Z, equal to 33 by 5. Okay, now if you divide this matrix, divide this second equation by 11 by 5, what you got? 11y minus z equal to 3. 11y minus z equal to 3. Now see here, you got how many unknowns? 3 unknowns are there, x, y, z. Okay, as well 3 unknowns. And you got how many equations? Only 2 equations are there. Only 2 equations are there. So it is not possible to solve, because to solve, if there are 3 unknowns, to solve this one, you must have to get at least 3 equations, but there is only 2 equations. So it is not possible to solve this. Okay, so that let's see how we can find out this solution. Okay, so here we consider, suppose z equal to k. Here we consider, suppose z equal to k is the solution. Z equal to k, we consider this one. Let z equal to k. Okay, we consider this solution. Now if we put z equal to k here, then what you got? 11y equal to k plus 3. 11y equal to k plus 3. Now y is equal to what? You have to divide this equation by 11. Then it will be what? It will be what? 3 by 11 plus k by 11. That means when we consider z as k, you got y is also in the form of k. Clear? Now you have to put the value of, z and y in the first equation. Okay, you have to put the value of z and y in the first equation. Clear? So what is the first equation? X plus 3 by 5, x plus 3 by 5, y. Okay, y means what? This 3 by 11, 3 by 11 plus k by 11, 3 by 11 plus k by 11. Now plus 7 by 5. What is z? Z is equal to what? K. Z is equal to k. As a whole, it is equal to 4 by 5. So after solving this one, we got x is equal to minus 16 by 11 k and 7 by plus 7 by 11. Okay, so you got three solutions. Z is k, and y equal to 3 by 11 plus k by 11, and x is equal to minus 16 by 11k plus 7 by 11. Okay, now you can ask me how we got infinite number of solutions, because here there is only one set of solutions. So how we can got infinite number of solutions? Now see here, we simply consider z equal to k, where k is any numbers. So if you consider k equal to 1, if you consider k equal to 1, then you got one set of solution. If k equal to 1, then obviously z equal to 1. Y equal to what? If you put k equal to 1, y equal to then 4 by 11. Similarly, x equal to what? It will be minus 9 by 11. So proceeding this way, whenever you consider z equal to 1, you got one set of solution. Again, you can consider z equal to 2 also. Then you got again one set of solution. That means what? We can take infinite values of k. We can take infinite values of k, and for that infinite values of k, we got infinite set of solutions. Okay, so for that infinite values of k, we got infinite set of solutions. So that's why the system has infinite number of solutions. Okay, so these are the three types. So in the first one you already got. First one, what you got? Whether the system is consistent or not, whether the system is consistent or not. And what you got? If rank of the matrix is not equal to the, if the rank of the matrix is not equal to the rank of the augmented matrix, then this system is inconsistent. That means there is no solution. So this one, if rank of A not equal to rank of C, the equations are not consistent. Okay, clear? And the second one, you got the system is consistent and it has an unique solution. Clear? This is the second one. This is the second one. And what is the third one? What is the third one? Third one is what? The rank of the matrix and the rank of the augmented matrix is less than to number of unknowns. Okay, is less than to the number of unknowns. So it has infinite number of solution. So you note down this question and try yourself. You note down this one and try yourself. Discuss the consistency of the following system of equations: 2x plus 3y plus 4z equal to 11. Again, x plus 5y plus 7z equal to 15, and thrice x plus 11y plus 13z equal to 25. Okay, so if it is consistent, then solve it. So you try this one. Clear? Now you can ask me if is there any doubt. Bhargav Sokya, is there any doubt?
Sir, till now, no doubt.
Till now, no doubt. So when you can say that a system of equation is consistent? Yeah, tell me, Bhargav. Anyone tell me when a system of equation is consistent? Asif Mohammed, tell me when a system of equation is consistent?
When rank of A is equal to rank of C.
Yeah, when the rank of A is equal to the rank of the augmented matrix. Okay. Okay, then I think it is clear to all of you. So listen it carefully. Only 12 students are present in the class. So I will give the attendance to only those 12 students. Okay. only 12 students are present in the class. So I will give the attendance to only those 12 students. Clear? So, okay, then that's all for today. Okay, then that's all for today.